we can start. Just two words. I would like to present you Orlando Barrera. He came from Texas, US, only for us. So it will be just a short trip. Short trip to stay here. The main topic of the speech is about the machine learning. One of the hot topic of the moment, AI, machine learning in a security environment, and it will be related to the models, right? It's a classification model. So
classification, great. Okay. All right. Well, thank you, everyone. Thanks for coming. A little bit late, but thanks for sticking around. I appreciate it. So, just to make sure everyone's in the right room, I think there's only one, but machine learning classification, the marvelous universe of models. My name is Orlando Barrera. Like I mentioned, just a brief introduction, who I am not. So I'm a technical account manager at Fastly, formerly Signal Sciences. So if you're familiar with WAF products, Mick Dalbrith created the lib injection, which is used in bot security, and then they spun off Signal Sciences. Signal Sciences got acquired by Fastly, so been there about 5 years now. What I am not a data scientist, and I'm not a data analyst. I am an active member in the Austin security community in Texas, as mentioned. So I did spend a lot of my teenage years in the Texas Hill Country. So I didn't take computer science in high school, but I did take equine science. That joke may not land here as it does in Texas, but equine science is horse science, right? So, and this is a photo of me doing paramotoring. So when the pandemic started, I didn't know anything about paramotoring, and I didn't know anything about machine learning or AI, but I had time, and so I started learning. And yeah, that's a hobby that I've taken up, is flying the paramotor. And with that, I just, like I mentioned, I started getting into machine learning, and let's see, make sure I don't miss anything. Scroll down. Yeah. So today we're gonna discuss machine learning and particularly classification of it. But the first thing I want to propose to you, all of you on the room today, is that there's something today that you can learn. There's some piece of knowledge that you can take away from this speech today, and hopefully there's something that you can apply within your daily life in security, or offensive or defensive security, whichever it may be. So going to the next one. Yes. Who's this talk for? Mainly beginners who may have a little bit of experience with machine learning or just have an interest in it, and they have some Python coding skills. We're going to go over a little bit of code today, so it's okay if you don't have any prior knowledge of machine learning. We're going to get you to a baseline, hopefully today, that you'll have an understanding. I believe that we're on the verge of a paradigm shift in computer science and code development. I believe we're shifting from developing code to training models. Similar to the paradigm shift from procedural to object-oriented programming, we're now shifting to programming, machine learning, and AI development. So instead of developing with algorithms and data structures, we're shifting to developing with models and data sets. So I'm going to say that again because I really think it's important. Instead of developing with algorithms and data structures, we're shifting to developing with models and data sets. So what we're going to go over today is, first, I'll briefly review what reflective cross-site scripting is and the different approaches to XSS classification. I'll continue by introducing supervised machine learning terminology and the basic workflow. I'll review my attempt at programming an XSS classification algorithm using scikit-learn Python module. And then finally, I'll demo a machine learning user behavior bot based on a classification model. Next slide. All right. So my goal for the audience today is I want to challenge you to think of a problem that perhaps only you can solve. How could you use machine learning to solve a problem that you might have in your day-to-day life or in your work? And like I mentioned, it's okay if you don't know anything. We're going to go over the terminology today and the workflow of machine learning. So what is machine learning? This is my definition of machine learning. Machine learning is basically tools, such as various machine learning classification models that act as semi-autonomous algorithms to help validate a hypothesis given out-of-sample data set. So given a set of attributes, features X, we can use machine learning models, a function of X, to help validate the hypothesis, Y. we can feed the machine learning algorithm attributes, which can then be classified based on the trained model. So today we're going to start with reflected cross-site scripting classification. We're going to keep the scope to reflected cross-site scripting just for the simplification of classification of that attack, right? We're not going to go to stored or DOM or any other forms of XSS today, just reflected. If you don't know what that is, it's basically an HTTP request that can include some unsafe data in a way, injecting, if you will, into, usually it's a web application where they're able to inject some sort of a script and potentially be viewed by others. So you see at the end, that variable, there's just a simple script alert that's attached to it. So, but additionally, we can use this methodology to inspect request bodies, headers, we can look at database files, and we could actually apply this to the same methodology to other injection attacks, such as SQL injection. You could do command execution or directory traversal, for example. So why XSS classification, right? I mean, it's kind of boring. I know it's been around forever. I used to work at hackers.org and slackers.org. They created the XSS cheat sheet. So I've been doing this for a while, and I thought this would have been, long gone and would have been resolved and mitigated years ago. But we still have XSS, and it's prevalent. As you see, that it's actually, it's one of the favorite techniques that hackers use to get an initial foothold and maybe pivot from there, right? So XSS does happen, right? It does. I know some people think it's lame, but it does happen in real life, right? You see here, Google, recently, you can find cross-site scripting on major applications, websites, and potentially use that for a foothold to pivot. So it does happen. It is a valid attack vector, so we're going to take a look at that today. What are some of the approaches that have been used in XSS classification in the past? So obviously Regex, that's one approach that's been used. I wouldn't recommend it alone. Regex can be difficult to update. It can be difficult to maintain, and it's not the easiest to scale, right? And Regex is prone to errors as well. So it doesn't work the best. It is an option, right? That's where we started, was Regex. People still use it, but it's not the best approach, I would say. It does have its place, but there are other options as well. So next. The next approach would be parsing and tokenization. So this is what you kind of see in lib injection, if you will, or it's used in the OWASP mod security core rule set as well. So it parses and tokenizes the XSS and does some classification based on that parsing and tokenization data. But again, this does have some drawbacks as well. It is effective, but it is difficult, I'd say, to update the tokenization and parsing libraries, for example, SQL or different databases. That's not always updated within the tokenization and parsing for those, if you will, query languages. So why machine learning? Basically, every time I speak to someone about a WAF, a DAS, a RAS product, antivirus, malware protection, the first thing that comes up is they'll ask me, well, what about machine learning? Are you using AI? Is there any kind of machine learning within your application? And I get it. Models are sexy, right? We all want to work with models. So here's your chance today to get an idea of what that would look like. But before, I want you to think about the term machine learning. What comes to mind when you think of that term, machine learning? This is what I envisioned when I first heard the term machine learning, some complex, machine. But there's several different types of machine learning. They're very complex algorithms, concepts that are beyond the scope of the presentation today. So we're going to limit our discussion to supervised machine learning, and within that, a subset of classification, right? So we're not going to discuss deep learning, reinforcement learning, unsupervised learning models, or ChatGPT, right? I'll briefly review some of the differences. So supervised learning is used with classification and regression problems. This involves learning from a trained data set using labeled data, which can be used to either classify or create classification and regression models. This learning process continues until we require the level of performance that is achieved. Unsupervised learning is used when clustering or dimensional reduction problems. This involves using unlabeled data and then finding the underlying structure in the data in order to learn more and more about the data itself using factor and cluster analysis. Reinforcement learning is where the agent learns from its environment And deep learning and the artificial neural networks is used in like TensorFlow and other libraries. So why I envision machine learning being like Skynet, what it actually turned out to be was more like a Rube Goldberg machine learning contraption. So this is what it felt like when I was trying to build my model, right? So to keep things simple, like I mentioned, we're going to look at binary classification. So basically, we're going to take an unknown URL or string and classify the sample as XSS or not XSS. So binary classification is just, think of the example of spam email. So it's either spam or not spam. So we're going to take a classification of XSS1 or not XSS0. So again, the types of supervised machine learning are classification. That's what we're going to be focused on today, and that predicts a categorical response. We're trying to classify something based on labels. The other type of supervised machine learning is linear regression. We're not going to look at that today, but briefly mention it. It basically just predicts a continuous response. I like to think of like a house price, right? Maybe you have the square footage of a house, and you're trying to predict the price. That's a continuous response. So that would be like your linear regression problem. And go, okay. Linear regression, just to briefly mention it, we're not going to focus on it, but this is an example of the diabetes data set, just taking the first 2 data points and creating a line. Basically, it's just an attempt, linear regression, to make a prediction, a best fit, if you will, of that line. Again, this isn't going to be CS 229. We're not going to get into gradient descent or anything too complicated, so don't worry about the mathematics of this. Terminology. So we need to be on the same page. Going to go over some terminology right now, just so we all have a common understanding of machine learning terminology. So model. A model is a specific representation learned from data by applying some machine learning algorithm. And a model is also called a hypothesis, right? So to train a machine learning model is to provide a machine learning algorithm with training data for it to learn. When we can use different classification algorithms, there's decision tree, k-nearest neighbors, there's several classification algorithms that are included in the scikit-learn library. And the machine learning algorithm usually have some inner parameters. So like decision tree, they have the depth or the number of nodes. Those are called your hyperparameters. We're not going to have to worry about that. Just be aware of the terminology that you can fine-tune some of those models with these hyperparameters. Scikit-learn out of the box makes it really easy just with the default values that usually you don't have to mess with these hyperparameters. So like I mentioned, we're not going to go into depth on the hyperparameters, but just be aware that you can fine-tune some of those models. So training. The idea is to give a set of inputs or features for training, and it's expected output. So you label. So you have a set of input, which are your features, and then within that, you'll have a label. And then we'll map new data to one of the categories that it was trained on. In our case, it's going to be XSS or not XSS. So any new data that we map to it is going to be called out-of-sample data set. And then our prediction. So once our model is ready, it can be fed a new set of inputs, which it hasn't seen before, to make a prediction. So it will decide what that label would be. Right? So we'll test our model with some samples that it wasn't trained on. Again, this is called out-of-sample data sets. All right, so some more terminology. A target label. So this is basically a variable, the value that we're going to predict with our model. For example, you could have a label of fruit, and you could use the name of the fruit, like an apple, orange, or banana, durian, right? So that would be your label of fruit, the label, the name of the fruit. In this case, we're going to be using binary classification, so just 1 or 0. It's going to be XSS or not XSS. Think of hot dog or not hot dog, right? It's simple binary classification. I don't know if y'all get that either. So feature. Basically, the feature is an individual measurable property of the data. It's a set of numeric features that can be conveniently described by a feature vector, right? So feature vectors are fed as input to the model. For example, in order to predict the fruit, you may use the color, the smell, the taste, and make a numeric representation of those features. Right? So terminology, machine learning, we should be on the same page. So you're thinking to yourself, that's it? That's all it does is XSS? No, and not XSS, right? So this is the hello world, the iris data set. This is like your hello world of machine learning, if you will. It basically contains 150 records with 5 attributes. The petal length, the petal width, the sepal length, sepal width, and species. So in this case, the species is the label. That's what we would be predicting if we were trying to make a model out of this data set. The matrix and vector notation is used to refer to the data. The data is usually in matrix form. We separate each row of the matrix is a sample, an observation or data point. So each row is a sample. Each column is a feature or an attribute, and one of those columns is going to be your label or target. Sometimes it's actually a response as well, but that's what we're trying to predict is one of those columns is going to be a label, and that's going to be what we're predicting. In this case, it would be the class label of what the species is. Right? So you could have all those species names, and you could label it 0, 1, 2, and that would correspond to one of those species, that class label. All right. Hopefully I'm not going too fast. I know it's okay. I'm being aware of our time. So supervised learning classification. This is the algorithm that we're going to be going through, our kind of workflow, if you will. We now have a common terminology, so we could discuss what it would look like if we were to feed some sample data set into a machine learning algorithm. This would be the basic workflow for any model we want to create. In our case, we'll be using URLs to train data and label that data as XSS or not XSS. And once we've trained some data, then we'll be able to use that model to make some predictions with new data it hasn't seen. So I started looking at some previous work before I started this, and I just came across this white paper, and they did something similar. The problem I have with white papers, though, they never include code. Right? It's like they have this great idea, but they don't show you how to actually do it. So I wanted to take this white paper and actually make a practical application out of it. This example here, they had a data set of 1,000 samples. 600 were benign and 400 were malicious. They had 10 different machine learning algorithm or classifiers, and their accuracy, the highest accuracy score was 97% from this research paper. So this is the set of features that were used. If you look at this, there's no regex, there's nothing actually other than some Boolean and integer values. They're just counting. What is the count of how many times I see HTML or certain strings, right? It's just integer or Boolean values. There's nothing else there. It's just an integer or Boolean value as far as their feature set, right? So if you look there, that's what they used within that white paper. And the workflow. Basically, this is the same workflow we're going to go through. It'll consist of gathering samples. We're going to normalize the data, and then we're going to add a label of XSS or not XSS, basically 1 or 0. And then we can assign any features to that set of samples, and then we'll train a machine learning algorithm. And then once we're done training it, we can test it with new data that the model was not trained on. And then we could compare the results, right? So if you want to follow along, I have a GitHub repo here with a Jupyter Notebook. So feel free to take a look at that, follow along while we're going through this. It might help. I'm more of a visual, so I need to see code to follow it. But basically, just go to Barrera, GitHub, Barrera, and you should be able to find this code. So the process is scrapers, a lot of scrapers. That's what I started coding. So I had to write scrapers to create a large corpus or a data set of samples that I could then label. So I used Google Trends for different geo regions, and then I would gather a list of the URLs on those top trending pages. So I collected almost 45,000 samples, and I labeled those as not XSS, right? And then I gathered samples of XSS. So in that research paper, I think they had like 400 samples. I gathered almost 39,000 samples of XSS from XSS.com. Again, this is all on that notebook if you want to take a look at it and add to the data set, but it's there. So in total, we now have a data set of samples. They're labeled XSS, not XSS, or normal, and you have your benign samples and your XSS samples. So we've labeled those, and now we could vectorize them. You look, okay, that's just showing here. Data vectorization feature. So I created a function that will take an array of URLs, strings, and convert the samples to a matrix. Each row in the samples has been vectorized. Each column contains a feature such as the count of certain words or escape characters. So basically, this will allow me to take a large set of samples and make predictions on them using that getVec function that I created. So before we get that, we need to discuss word2vec. So basically, word2vec is a recent breakthrough in the world of natural language processing. It's published in 2013 by, I think, some people from Google. Basically, the algorithm uses a neural network model to learn word association from a large corpus of text. And once trained, it can make a relationship based on those words or partial sentences. So the common example is the relationship of queen to king is like woman to man, or you can say the relationship between queen to woman is like king to man. So it's the relationship between words is that it creates a vector of that. So how does it done? Word2vec, it uses a representation of two algorithms, continuous bag of word model and a skip-gram model. You don't have to worry about all that. That's just for information. But basically, what it does is if you have a sentence, given a sentence like this, the output would be a vector. Right? So I could use that word2vec to vectorize a sentence, if you will. But rather than use that, I decided to use doc2vec. This was just an improvement on the word2vec algorithm. Basically, it uses a representation of a document regardless of its length. And the word2vec will compute the feature vectors for every word in a corpus. This will compute a feature vector for every document in a corpus. So a little difference, but this is an improvement. The same team that created word2vec, or at least some of them, worked on this as well with Google. So doc2vec is what I used on the background. You look there, that's part of the code to actually create a model, and then it's saved for each one of those. If you look there, yeah, it's may not make much sense, but that's you don't have to worry about that right now. That's basically it's just taking a sentence and creating a vector out of it, right? A numeric representation of that with some relationship between them. So once I had that vector, I decided to add a small subset of similar features that the white paper had. Right? So, for instance, using the count of certain tags or certain special characters. So just taking the count, not actually parsing it or doing any registers, just counting how many times I see any of those special features or characters, right? And then with that, I'm able to append it to that previously created vector. So Python has several libraries for working with vectors and arrays such as NumPy. So if you're not familiar with that, it makes it really easy using the Python NumPy to append and modify vectors. All right, so we've looked at reflected XSS. We've gathered over 83,000 samples for our data set of XSS and not XSS. And we've applied binary classification to those samples. And we vectorized the data into what we see here as our features. Now, the next step is to train our various machine learning algorithms with our data set and test the results with some out-of-sample data. So our goal, again, is to train our models and generalize our predictions of samples that it was not trained on. So if you look here, that test sample is just a URL. This is the vector that's created, and that would be an example of the label that we've attached, right? So we have a string, we've created a vector out of it, and we've added a label. Make sense? Everyone on the same page with that? All right. So this is where scikit-learn comes in. I love it. I think it's like I like to think of it like the infinity gauntlet, if you will, of various machine learning models. The classifiers that it has, it allows you to focus on creating models, right? It's almost like we live in a marvelous universe of models, right? Our perception is represented by models, which we're continuously trying to define and classify. And scikit-learn makes it really easy to use these algorithms to create models. You don't have to go into the math of nearest neighbor or support vector classification or decision trees. You just have to prepare your data, normalize it, and then you could use scikit-learn to create models from it. So training the models, right? This is an example of just training a model with the k-neighbors classifier. So the steps, the workflow of training the model. Basically, step one is you import the class that you plan to use. In this case, we're using the importing that K-neighbors classifier. Step two is you instantiate the estimator. The estimator in scikit-learn is just a term for a model. So you're just creating the model in that second one. You're just instantiating that K-neighbors classifier. Do you see that n neighbors? That would be considered like your hyperparameter. So there's a lot of other things that you tune within these algorithms. Normally, you don't have to mess with it. Out of the box, scikit-learn is really usable. And then step three is you fit the model with the data. Fit is basically just training. It's just another word for train. So where it says fit, that's where we're training our model. That one line is we've taken all that x, our vector, our y, and we just train it, right? And that's one line. After all that work, all that data gathering, normalizing, vectorizing, comes down to one line. is the fit. So you train your model, and then you make a prediction from it. So you pass it new observations. You pass it samples that it hasn't seen or out of sample data, and then you make a prediction using the predict function, which seems kind of obvious, right? But then how do you compare the model performance, right? So how are we going to train and test various machine learning classification algorithms? Well, luckily, scikit-learn provides a train test split function. So the train test split is a model validation procedure that allows you to simulate how a model would perform on new or unseen data, again, that out of sample data set. A goal of supervised learning is to build a model that performs well on new data, just data that it hasn't seen, it can make a prediction on. And this allows you to estimate the likely performance of a model based on that out of sample data set. So just an example of what that looks like, that scikit-learn train test split function. A few things to note is we don't want to have overtraining or overfitting of our models. So basically that means we're testing the model on the same data we trained it on, right? You don't want to do that. So what we do is we split that data. And what I've done is a 70-30 split. So I take 70% of the data and I train the model, and then I test it with 30% of the data that it hasn't seen yet. So this is one method. There's actually another method called cross-validation, a little more complex. We're not going to get into that. I just used a 70-30 split. And we use a random state of 42 for reproducibility. And because the ultimate question of life, the universe, and everything is 42, right? But basically, that means if we were to retrain it with that random state, it's not going to be random, and we'll get the same results. Classification report. So this will give us some information on how well our model did, right? So this is for support vector classification. Basically, precision is the percentage of correct positive predictions relative to the total positive predictions. Recall is the percentage of correct positive predictions relative to the total actual positives. And then the F1 score is a weighted harmonic mean of precision and recall, but basically the closer to 1, the better the model on the F1 score. So this is one of the means of determining how accurate or how well that model performed. Confusion matrix. So this is another, I like using confusion matrix. For me, it's a little simpler to see. Basically, it just tells you what the predictions were. The thing to observe here would be your type 1 and type 2 error, or your false positive, false negatives. You want to have low type 1 and type 2 errors. That's the whole goal of a confusion matrix, right? It's a little easier to see. So here, if you look at this, the type 1, type 2 errors would be, your results that weren't correct in that prediction. And this, let's see, is there anything? No, I think that's it for the confusion matrix. There shouldn't be anything. Well, one thing to mention is this MLP classifier is actually a multi-layer perceptron classifier. So using neural networks is not as simple as some of the other ones, but just make note of that. Training accuracy. So these were the results that I got from my script, my models with training them. If you recall that white paper, the highest accuracy they had was 97%. So you see some of these models actually scored quite well. The lowest one was actually a 94.8% accuracy score, which is pretty well, I would think. So comparing that like I mentioned to the other one, I think just from taking that vectorization and adding those features, been able to reproduce and actually make improvements on that research that was done. Okay, so this is an example of a code snippet where we create an array of strings. The test XSS string array is passed to our getVec function, and that converts each string in the array to a vector. The XNew matrix is then passed to the trained machine learning models to make a prediction if the string is labeled XSS or not XSS. So in this example, we're taking just the generic string out of the sample data set, we're vectorizing it, and then we're going to make a prediction. And that's what it would look like. Each one of those models will make a prediction. We faceted those models that we trained. You see one of them said it wasn't XSS, but we use a weighted average, and then we would, in some, make some determination if that's XSS or not. And you see in this example, that prediction result was XSS, as we would expect, right? All right, so let me see if I could get this to play. I want to do a demo of this and see if this is going to work. Maybe. Okay, and then find the play. Okay. So this is the Jupyter notebook. If you were following along, I'm just going to kind of walk through. Let's see. All right. There's the GitHub repo. We kind of went over this, the basic workflow. Let's see, yeah, just going over some of the sample sets, the code that is used to gather some of the sample data. This is the getVec function. If you're curious, you can look at how we're vectorizing that using that doc2vec we discussed. Once we vectorize it, we're adding additional features to that vector. For example, the count of special characters, nothing really too crazy, but what you would expect to see in a sample of XSS. Here we're using that function, that getVec, to create a set of features. Again, we pass that in and then we label it. And here's where we train the model. We train it, and again, our results, and the accuracy score from all those models that we trained. Training a model is just that fit function, so there's nothing too crazy there. Once you have your data, you normalize it, vectorize it. There shouldn't be anything too crazy to training. And then once we are satisfied with the results, we don't want to throw away data. So we retrain it. Before we had the 70-30 split, so now we take all of that data and we retrain our models again with all the data, right? And then once we've retrained all the models, we're going to test it with samples that it hasn't seen, samples that it wasn't trained on. So this is out of sample data. And then here's just a simple example of taking those samples and then the results that you see. Yeah. So I mean, does that make sense? Hopefully you got your mind working. You're thinking of some way that you could potentially use this in your own data. It doesn't have to be XSS, but you can apply this as SQL. You can apply command injection. What have you. This is a Python code I wrote just to test large samples of data. For example, that was 1,000-something samples. But you could use this offline in database files, right? Maybe looking for SQL injections or certain things. So not too complicated, huh? I mean, and once you understand basic terminology, the basic workflow, for me at least, what I found the hardest part is collecting data, labeling the data. Training the models is easy. Testing it, there's functions to do so. It's really bringing your expertise and your knowledge into what need the feature set. That's where it comes in, is what features need to be identified and how you're going to label those. Okay, I know I'm going fast, but there you go. Okay. All right, I know I'm going quickly there, but it's been a long day, and I know you are tired, so I appreciate your attention and sticking around. But what's next? what's next with this, right? Like I mentioned, what I envision would be maybe perhaps having a community OWASP machine learning classification library. I could envision a data set that the security community contributes to, right? For example, XSS, you have a data set labeled. Maybe the community starts creating SQL injection data sets, direct traversal. And what I see is potentially having your something similar to lib injection, right? But an OWASP machine learning library core rule set, if you will, right? That the community is contributing to. They're creating models that can be used within products, security products for detection, for offensive defenses. I think the key is mainly classification. Is taking that and being able to classify it. Once you have a classification, then you can take some action on that, right? So, like I mentioned, what's next? What I've looked at is potentially expanding on some of this work for machine learning, creating some more libraries. But what is really interesting to me was bot classification. I've seen this plague a lot of my clients is bots, and there's a huge broad definition and classification of bots, client-side detection and whatnot. But for my use case, I just wanted to focus on client-side browser automation classification based on user behavior. So I wanted to kind of take the same approach that I did with XSS and see, could I use that on the client side, detecting mouse movements, key presses, time deltas, etc., and create a machine learning model that could detect, is it human or not, right? Is it a bot or not, based on user behavior analysis. So I started working on it. And what I wanted to have was some client-side JavaScript to gather user behavior and a small machine learning model that could run in AWS Lambda serverless. So I could just call it. I could just call it a function, and it would give me a result. Is it a bot or not? And I wanted an API-based classification model that I could call from various web applications as well. So again, we used AWS Lambda and the serverless Python function to run our machine learning model that we create. If you look there, I think it's just showing some of the JavaScript. This might be okay. Yeah, so this is the user behavior JavaScript that's just injected client side. It's going to collect, the script runs, it collects key presses, mouse movements, etc. It has some headless browser detection as well. That's not really used in the machine learning part. It's just for verification if the model was correct or not, right? Next, collector API. So on the AWS Lambda, I pass all that to this collector API function. I pass this vector, and then the collector API will make a prediction based on that. So that vector X is what I've collected from that user behavior JavaScript. I pass that up to this collector API, and then that machine learning model is making a prediction based on that that vector. So here it's saying it's not a headless browser, and it's not a bot. Right? So 0 means good in this case. This is an example of that AWS Lambda function. If you look there, it has a bot resource I pull in from an S3 bucket. So that's the machine learning classifier was only 30 kilobytes, which is quite small. Was able to load that. You could load various models and again have the same approach where you have a weighted average based on those results. But this was small enough that we're able to do everything within the Lambda function pretty easily. And then this is an example of that collector API. Basically, it's just you see the keylogger, mouse movements, right? Timestamps where you've clicked. It's just taking deltas on those and passing all that and then vectorizing everything, right? That's the key, is creating a vector, taking all of this data here, vectorizing it to that what you saw in that X array. And then once that's done, that gets passed up to our Lambda function, and a prediction's made. So if you look here at the bottom, right there, prediction 1, and of course it says it's a headless browser because in that test I was running, it was a headless browser. That was the actual array. This is what got passed. So if you saw from the last example, this looks completely different from that other vector. I tried it in, well, I'll show you in the demo, but yeah, that's what it would look like. And then CloudWatch, right, just to monitor results on the back end as things were coming in and predictions were being made. And of course, you could use this to trigger other functions, other actions within within that. So this was one approach, and then briefly, let me bring it up. I'll show you some demo of that as well. So this is a demo of that bot classifier using user behavior analysis. I'll try to speed my way through this. Okay, so this is just an example application just for testing on localhost. It's nothing out there, just to test the input. That's that user behavior JavaScript. Just going through some of the code, which is showing testing plugins. That's where it's it's just getting the headless browser score. That's just for identifying. Let's see, user log. That's where we're gonna find the functions for as far as mouse movements, clicks, details, things like that that are going to be collected here. Yep, some more user info. I don't use this, but you could use this as well for other identification. Yep, this is the clicks. Now, this is the part that I use mainly, is the clicks, mouse movements, keylogger. Well, everything's redacted in the keylogger, so it's just how many key presses. So here's an example of inputting some data manually. And that will be passed over to the collector, right? And that's the vector that's created and the prediction that's coming back. So this is to show you entering things manually. It recognizes it as it's not a bot. That just shows you the payload of what was passed up to the function. All the vectorization happens in that AWS Lambda. This is just what's being passed up through there. You see it's just a bunch of key presses, and that's data's redacted. This is the AWS machine learning model, the collector, that collects everything. Pull it in that bot resource. That's a machine learning classifier. Then we're grabbing all that data as it comes in, JSON. A lot of this isn't used. I just grabbing it, and then I set up local variables, delta y, delta u. That's just what's the total. I'm not going to show all that detail. And then a prediction state. This is, again, once you have the vectorization, it's really simple to make a prediction. Just call predict, and then we'll look at some of the results. See, just to show test that it's running in Lambda. And I think I go to CloudWatch to show the logs for testing as well. And that's a test just of some of the data. You see what got passed in. You see what the vector that was created, and then the prediction. All right. The next one, this is using the Chrome Dev Tools recorder, a session replay, to see if it detects it. So this is Chrome running, sending, just replaying that test, and then going to CloudWatch to see that request. Because of course I can't do inspect while that's running. So if you look here, that's what was passed in, and prediction made. Right, so it's saying yes, it's browser, it's Chrome DevTools, and it detected that using that machine learning model. And that's the vector that it got passed in. And you see it looks totally different than the other one, right? But the machine learning algorithm was able to detect that there was an anomaly there. The Selenium script. So I wrote the small Selenium script to do some tests. Here you go, fully automated browser. Just these are kind of common tools that I think for automation that you would run into. And then I even tried to do some evasion, like just random key presses, random time, mouse movements. I tried to evade myself, if you will, like playing offensive, defensive. So that runs, and then we'll go back to CloudWatch and see. Yeah, and then look at that vector. It's completely different, but it was able to make a prediction. So you see Selenium, completely different than Chrome DevTools as far as what was passed in as far as vector, or what got vectorized, right? Okay, so hopefully that gave you an idea of how you can apply machine learning models to other applications, not just XSS or SQL injection, but I think there's really switch this back. Yes, today. No. So again, the machine learning workflow. That, I think this is the key, right? Everyone has their own data, they have their own ideas, features. This is the basic workflow, what you're going to go through. It starts with asking the right questions, right? You have the security knowledge. You know what, you have that specialty knowledge that maybe someone else doesn't have, right? So you can apply that, asking the right questions. Preparing the data, that's going to take the most time, I think, is normalizing the data, collecting the data, vectorizing it, selecting the algorithm. If it's classification, that's pretty simple. But again, we discussed there's linear regression. There's some other problems. So classification has its use, but it's not the only algorithm that you may need to apply, right? So again, you have deep learning, you have other algorithms. Training the model, pretty straightforward. Once you have your data, you can train it, and then testing the model. You do that train test split and make the accuracy results or confusion matrix right out of that. So again, I just want to kind of just community challenge, if you will. Does everyone think it is feasible to have a web app security machine learning core rule set, model library similar to the OWASP core rule set that the community would contribute to? I mean, is that something that I see it as something valuable to the community? You had a data set, you had a set of models, and you could apply open source. You could bring it into your own project. You could extend on it. So that's where I kind of see this project going, is maybe an OWASP machine learning core rule set. So that's hopefully in the next step if I get time. Yeah. So like I said, I started the presentation asking you all to challenge yourself. So I want to end the presentation asking you to challenge the community, the security community, to think of ideas. Well, how can you apply machine learning? Right? This is one example of XSS and maybe bots, but what other areas? Can you apply the machine learning models and algorithms and extend that? Because, like I said, I think that is the future of Dell. We're going to be training models and collecting data sets instead of algorithms and data structures. All right. Now, with that, I'll open up to questions, and feel free to add to the code, or if you have any pull requests or any comments or recommendations, feel free to ping me on GitHub as well. But open up to the room. Is there any questions? Anybody want to discuss anything? Yeah, please.
I'm wondering, specific to the machine learning bot build up, how did you build your data set and how big it was?
That's a good question. So the data set wasn't that big. It was me just running through. I don't remember how many samples it was, but that's how I trained it. I trained it on. I created some code out, for Selenium and for Google Chrome, and I collected that data set just using those whatever tools were available for automation. I collected that data set and then manually was navigating the app, clicking around and stuff. So it was a combination of. I had a set of automation scripts, and then collected that data, and then spent some time just browsing or having people go to the app and having user behavior interaction. So that, and then from there I could classify, okay, this was user behavior, and this was scripted. And then once it was trained, the model could make predictions on data it hasn't seen. So, but I don't know how big it was, so hopefully that answers your question.
Okay. And the follow-up questions is, what were the main features discriminated Selenium versus human? You said that you tried also evasion, and you said that you're based, at least what I saw, the main features were like length of the user click or how many clicks were there. What did you observe?
So the question, just to repeat for everyone, the question was, what were the main features observed between the scripted bot and then the normal user behavior?
Because yes, especially you tried evasion, right? Something.
Right, some evasion, and I tried some evasion. So yeah, the evasion was, like I mentioned, I tried different lengths, randomness, different mouse movements. Honestly, the main feature I think might have been the mouse movements. Honestly, the delta and the time between. Even though I've tried different times of mouse movement, it seems. I mean, that's just my observation. I don't have any data to back that up. Just in my observation, I really think it was how quickly. Yeah, because it's taken a delta between. Okay, you start here, and here's your movement and the time, and it just, I don't know if the scripts they just goes directly to it, and I tried moving, adding some randomness to it. Not so much as far as I didn't see the key presses, right? Because I did notice if I wasn't interacting with the page for a while, even as a user, it would say, "Oh, you're a bot," because you haven't interacted, right? So there was that delta there that was too large. But for my observation, I think it was a mouse movement, a combination of mouse movements was the main thing I saw. Yeah.
Makes sense.
Yeah. Any other questions? Yes.
Yeah. How robust were your XSS detection models against false positives? So if you give it a benign string that's slash script slash a slash alert, that kind of seems like an XSS. How did it perform against those kinds of things?
The question was how robust was the XSS against false positives and out of sample data set. Actually, surprisingly, it was pretty good. I did test a lot of random just script or alert. That I think is where the tuning of the hyperparameters are training the models are adding additional features to it, right? So that's where if you do encounter false positives, that would I think be one of the difficulties of machine learning. If you don't have a continuous feedback loop to train that model again, right? You're gonna have to label that, identify it first as a false positive, and then figure out, is there features or something within that, and then maybe retrain the model. This model did pretty well. It did have a few false positives, like if I had script, or a long string of something, it would say, oh yeah, that's an XSS. But overall, surprisingly, it did well, better than I've seen in some public available products that are being sold. Hopefully, that answered your question.
Yeah, absolutely. Thank you.
Any other questions? Once, twice? Yes.
Do you know if there are some application firewall solutions that are based on this concept?
What was it?
Application firewall solution like
Application.
Web application.
Yeah, web application firewall. Yeah.
Oh, web application firewall based on. That is what I would like to get to. The question was, do I know if there's a web application firewall based on this? There is something I saw recently. I'm trying to think of the name. There is one that was open source. I'll have to look it up and get to you. There was one that's open source that was based on machine learning, but they didn't provide the data. It wasn't, it was open source to where you could use it, but they didn't have the data and they didn't have the models. Everything wasn't available. I'll look for that and see if I can get to you after the talk. But there was one thing I saw that was a web application firewall using machine learning models that was available, and it wasn't. I think it was a free product. Yes, there's one company. It's on the tip of my tongue. I'll have to look up on my computer after. But yeah, there was one like this. But this, I haven't seen, and I can't recall what theirs was coded in, but I haven't seen something similar to this in Python and available within the OAuth or the security community. But yes, that's where I want to get. I think that's the right. You're asking the right question.
all major vendors already embed.
They embed, yeah, but it's not open source. It's not.
No,
yeah.
vendors. I mean.
Yeah, vendors. Yeah, yes. And the problem with that is, I guess they do, but you don't know to what extent, and you don't know how accurate. I like to be able to see their data set and how they're classifying. Yeah, so yes, that again to my point that whenever I talk about WAF or DAS, that's the first question that comes up is, well, what about machine learning and AI and yeah. Anything else? Any other questions?
So when machine learning is going to fail is when you cannot classify the data set initially.
When machine learning fails, when you can, well, you could use unsupervised learning. So if you're not able to label it, you can use unsupervised, and it would be more of a clustering problem, right? So the machine could learn from the data, right, and it would find anomalies, which is a little out of scope, but yeah. In that case, you would probably choose a different approach. Yeah. The question was if you're not able to classify it, right? How would you use machine learning? So again, probably a different approach of unsupervised learning, maybe deep reinforcement learning, everything now, right? So yeah, it could get pretty complex if you get but for the sake of simplicity and classification and make it something that's usable within, in-house product that, your team and your company could use maybe. This, I think, has, really good applications just for simple classification.
So it really to keep on training models and keeping on like once a day, keeping track of what is passing, the train, track and train.
Yes.
The process to deliver this approach.
That's a
or
good
to an application, or we needed to prepare something before and then start monitoring.
That's a good question. The question is, do we need to keep training the machine learning model, or can we just train it and use it, as is? That depends. Ideally, yes, I would want something where it could, a feedback loop where, okay, I have data coming in, I could label, I could retrain the models and update it. But if you have high enough accuracy and you're okay with, the accuracy score, then if you've trained the model and it works, there wouldn't really be a need to retrain it unless, for example, you have the false positives, false negatives, and and you're not, that's not acceptable, right? Whatever your program, whatever your use case is. But yes, ideally you would take that user input and have, retraining the model and that would be ideal. All right, anything else? All right. Well, again, check out the GitHub repo. Feel free to add any examples, any comments, pull requests. I'll take into consideration. But yeah, thanks. Thank you everyone for attending.